Okay, welcome back. We're going to be finding the distance between 2 points now. This happens a lot in math and in the real world. We want to find a straight line distance between two things, so like maybe 2 points on the map or whatever. So we can always throw it on a grid um, and figure out what those 2 points represent. Here, we're just going to use a point 1 in the x and 1 in the y, and 4 in the x and 5 in the y. So this is just in the first quadrant. So we'll call this a level 1 type problem. So how far is it from that point to that point? And what we could do is always draw a right triangle. We could drop a vertical line straight down, and we could drop a horizontal line going across. And you see that vertical and horizontal make a right angle, don't they? So this makes a right triangle, and you could count up the side. So this is a distance that is 3 long, right? And this distance here is 1, 2, 3, 4, 5. No, yeah, 5. And so this distance right here would be able to be found by using the Pythagorean theorem, right? So I have leg squared plus leg squared equals the distance squared, and I'll just call it d for now. So this is 5 squared plus 3 squared equals d squared. So this is 25 plus 9 equals d squared. And add them together, so I get 34 equals d squared. And square root both sides, so I get the square root of 34 is d. Now, the square root of 34, let me pull up the calculator. Square root, and it should be less than 6, but greater than 5. And it says it's about 5.83. Okay, and try to picture, does that make sense? It should be greater than 5. So 5.83, looks like it's about right. Okay, so I just counted the squares, but what if they gave us some squares that were pretty far apart? So like this one over here and this one over here. Would you want to count up all those squares? Let me close that. It'd be a lot of squares to count. It might take you a while. So there's a faster way, right? If I want to find that distance, well, this is -6, and that distance is 9. So I have 9 and -6, so I could add them together, the absolute values. Or if you think about it, if I took 9 and I took away a -6, that would be the same as adding, right? So that would be 9 minus a -6 is 15. So that would be 15 in the horizontal direction. And when I take the vertical direction, let's see, it's 6 up and 6 down, which if I add 6 and 6 I get 12, but if I think about it, it's 6 minus a -6, which is 12, right? So minus and minus is plus. So I have 15 in the one direction and 12 in this direction. So 15 squared plus 12 squared equals the hypotenuse squared, which I'll just call d. Right. D squared. Okay, so 15 squared is 15 times 15 is 225. If you want, you can write it out. 5 times 5 is 25. 5 times 1 is 5. Plus 2 more is 7. Placeholder. 1 times 5 is 5. 1 times 1 is 1. Add them together. So 5. 7 plus 5 is 12. And 1 plus 1 is 2. So 225. Okay, plus 12 squared. 12 times 12 is 144. Equals d squared. So I add 225 plus 144. Get 9, 6, 3. So 369 is d squared. So that means d itself would be the square root of 369. And I don't know off the top of my head what that is, so I'm going to pull up my calculator. Square root. And it says 19.2. Approximately 19.2 is the distance from that point to that point. Now, in general, that's what mathematicians like to do, is say things in general. So if I have any point here and any point here, I'll just call this x, y, right? And let's just call this point 1. And we'll call this one x, y, and call it point 2. How far apart are they? So what I could do is I could take whatever my x value is at point 2, that distance, it's the difference between, right? The difference is subtraction. So x squared minus, or not x squared, x2 minus x1. These subscripts actually represent the number of the point, not doing anything to it. Just to distinguish between this one and this one, I'll call this one x1 and this one x2. So x2, that distance, minus that distance. So actually this notation helps us keep things straight. So x2 minus x1, and I'm square it, right? So that's the distance right here in the horizontal direction. So this distance right here is the difference of the x values. And then this distance right here is how far vertically we go. So that's the difference in the y values. So I'm going to take whatever the y2 value is, take away the y1 value, and square it. And that should be equal to d squared. So d itself will be equal to the square root of all of that. Okay, and we call this the distance formula. Now let's see if it makes sense with our first example. So I took this point 4, 6, and I took this point 1, 1. So the difference in the x values was 4 minus 1 squared, so this was 3 squared. And the difference in the y values, so 6 minus 1, which was 5, plus 5 squared. And that's exactly what I did, didn't I? But I switched the order, but it doesn't matter because they are commutative. Okay, so 3 squared plus 5 squared, I got 34, and the square root of that is d. Okay, and just check to make sure it made sense with the other one. So I took this point over here, 9, 6, and this point over here, -6, -6. So I take the difference in the x values, so 9 minus a -6 squared, which 9 minus a negative is actually plus, so it becomes 15 squared, plus the difference in the y values, 6 minus a -6 squared, which is 6 minus a -6 is 6 plus 6, which is 12 squared, and that's what I did. So 225 plus 144 equals d squared, and the square root of that, I came out with square root of 369, which was approximately 19.2. Okay, there it is.